Let's see how we've done. What would the parameter be here? Mu diff. And how would we define mu diff? Yes, sir. True mean of differences, or true mean difference in the number of words remembered. And you do have to give direction. So just like when we're doing a mu1 minus mu2, for a mu diff, you do have to show the direction of that subtraction. What is the statistic here? X bar diff equals 1.5. What would our hypotheses be here? The null is mu diff equals 0. Yes. And how did you know it was supposed to be a greater than rather than a not equal to or a less than? Yeah, so kind of what I keyed in on when I was looking at this. We have strategy 2 improves memory. So you would expect when you do that subtraction, then the average would come out to be a positive. If strategy 2 is improving that memory score, because we did strategy 2 minus strategy 1. What would the name of the procedure here be? Yes. Sorry, one more time. One sample t-test for mu diff. There is also another way to state that. There's nothing wrong with the way you stated it. That would get full points. Sometimes you'll also see this referred to as a paired t-test for mu diff. Either one of those ways of writing it is correct. We have one sample, 2 pieces of information for each individual that was paired together and then subtracted. So we have one sample, or you could call it a paired t-test for mu diff. Checking those conditions. What's our first condition? Randomness. Do we have randomness? What did it say to give us randomness? Yep. 32 seniors were randomly selected. Right here, when you go looking for your randomness condition, this is where you can double check that you chose correctly, whether it's mu1 minus mu2 or mu diff. We have a single sample here. What can we say because it's random? Like, why do we care about the randomness? Yes, so that we can generalize to all our seniors, to our population. What's our next condition? 10%. Do we meet that one? Yes. There need to be at least 320 seniors in order to get our 10%. We are kind of making that assumption, but we're showing that we're checking that there. Why do we need our randomness? Or sorry, not randomness, 10%. Yes, we need to check that sampling without replacement is okay. That means that we have an independent random sample. And the last thing we need to check. Normality. Do we have normality?
Yeah.
Why? Central limit theorem. Please keep in mind it's not enough to just say 32 is greater than 30. I need to see that, but then you also need to take the next step and say that means I can use central limit theorem. Just one or the other is not fully sufficient. Show the sample size, compare it to 30, and that does or does not give you central limit theorem. Why do we care about this? Yes, it means the sampling distribution. If we did every single random sample from this population of size 32 over and over and over and over and over and over and over until we get them all, that sampling distribution would be approximately normal. General formula that we're going to use. Yes, standardized test statistic equals statistic minus parameter divided by standard deviation. What is our standardized test statistic in this case where we're looking at mu diff? T. Anytime we're looking at means, anytime we're looking at mu, it's a T statistic. What is our statistic? X bar diff. What's our parameter? Mu diff. How do you find the standard deviation here? Yes, S diff over square root of n. Please make sure that you guys are making use of the formula sheet on the test. I know we've gone over a lot of formulas. I want to make sure that you know when and where and how to use the different formulas. But if you look, this is the back side of the front page. Over here, it gives you the formulas for the standard deviation. It says for one population, for two populations. So you do not have to memorize those. You do have to remember in this case that we're using X bar diff, mu diff, S diff, but the basic formulas are right here. Last test, I noticed that a lot of people were kind of merging the two standard deviation formulas for one population and two populations, like where does the square root go? How do I know? When? Look at that formula sheet so that you don't put those things in the wrong places, because I saw a lot of really good stuff, but then I had to take off points because we didn't actually calculate it correctly there. What was our test statistic? 3.1427. I wrote out a couple extra digits just so you could compare yours against mine. So there's our test statistic. Picture. What's this going to look like? Flatter curve. We're going to put this 3.1427 whatever and then shade which way, left or right? Right. Shade to the right because greater than on our alternative hypothesis. Don't forget, on a t distribution, instead of doing n with the mean and the standard deviation, you need to do t with your degrees of freedom. We had 31 degrees of freedom here. What was that p-value? Yes, 0.00183 something. I only went out to the 1.8, but absolutely. And you calculate that using TCDF. You do need to show how you're getting that p-value. If on the free response part of the AP test, you just pop in a number for that p-value, they would count points off because you're not showing how you arrived at that number. So write down what you typed into your calculator, lower bound, upper bound, degrees of freedom. So far, so good? Awesome. What would our conclusion be then?
Assuming HO is true and mu diff equals 0, there is a 0.002 probability of getting X bar diff of 1.5 or greater purely by chance.
Yes, that would be, that's the interpretation of our p-value. So that's the first thing that we need to talk about. Assuming HO is true, mu diff equals 0, there's a 0.0018 or a 0.002 probability of getting an X diff of 1.5 or greater purely by chance. Remember to add this part on. It's always going to be the same as whatever direction you shaded up there and what your alternative hypothesis states. Okay, so that interprets our p-value. We still need to make a decision and reach a conclusion. What is our decision? We reject the null because it's less than 0.05. So what is our conclusion then? We have convincing evidence that the alternative is true, and then you've got to stick some context in there. So tell me what that alternative hypothesis means in context.
Strategy 2 improves memory.
Versus strategy 1, yes. Because 0.0018 is less than or less than 0.05, we reject the null and we have convincing evidence that strategy 2 improves memory over strategy 1. I showed my direction again here. Show direction when you are defining mu diff. Show direction in your conclusion. So there's no question about the way that subtraction was carried out. You guys feel okay about this? I heard a lot of really good stuff as we were going through this. All right. Once you're done getting the language down on this or making any corrections to your page, we're going to go ahead and flip over to the back. Important ideas, I feel like, are mostly a rehash of what we've done. I'm hoping that this pattern is starting to feel more familiar rather than when we did it with proportions and we were kind of first introduced to it. Same exact pattern with means. The thing you do need to watch out for, and this is another thing that I had kind of noticed show up several different times, make sure when you are defining your parameter, if you're using mu, you're defining a true mean. If you're using p, you're defining a true proportion. So if it's mu, make sure you say mean. If it's p, make sure you say proportion. All right. Big ideas. One sample t-test for mu diff or paired t-test for mu diff. That's the same thing as a one sample t-test for mu. We're going to use those same formulas there. You guys talked to me about this. T equals x bar diff minus mu diff over S diff divided by square root of n. You have a t-test on your calculator. Just like we had t-interval and we were looking at that the other day, there is a t-test on your calculator. We haven't used it much when it comes to free response questions. You have to show all the work for all the steps. So don't use the t-test if it is a free response question. But if it's a multiple choice question, you are absolutely welcome to use the t-test. There are options when you click on t-test where it wants to know, are you inputting data from lists or are you just inputting statistics? On what we did on the front side where you were given X bar diff, you were given S diff, you would put in those statistics along with your n value, and then it will calculate your standardized test statistic and your p-value. Ways to determine whether you are doing a mu diff or a mu1 minus mu2, a paired t versus a two sample t. With paired t, you have one sample, and those data are paired together. So for each individual person in this case, we had two pieces of data for the same subject, and then we subtracted those. One of the other things that you can look for, mean of differences. If mean comes first, that's a mu diff. Procedurally, that means you would subtract these paired data and then find your X bar. With two sample, you have two independent samples or two groups that you're gathering data from. This would be a difference of means. You're subtracting means. Here you have the average of the subtraction. That's a mu diff. Here you have the subtraction of your mu's, difference of means. You average them and then subtract. One other thing that I didn't write down up here. Sometimes your two sample sizes here will be the same number, like 30 from this group, 30 from that group. But if you have different n values, it has to be this one. If you have two different sample sizes, it has to be the bottom one. Because we can't pair the data if we have samples of different sizes. If anywhere in the setup of the problem they talk about pairing this data, obviously you would have to use the paired t. Once you guys kind of get this down into your notes, I want you to look at the bottom of the page, the check your understanding. And this is just simply trying to determine whether it's paired, so a mu diff situation, or is it a two sample? Is it a mu1 minus mu2 situation? So pull out any evidence. In addition to naming which procedure you would use, pull out evidence from the text to support your conclusion.
Phones from different people each.
They have 15 phones total. But what they don't have is 15 Samsungs or 15 iPhones. They have 15 phones total. And they've got them from all different manufacturers. So they've got some Nokias, they might have a BlackBerry in there, they've got all these different things.
So some of the variety comes just, it's not two things being compared, just a variety.
So do you have two, like what's the sample here?
15.
15. Is it one sample or two samples?
One sample.
One sample.
So it's just we need it for something.
Has to be that.
Okay.
Let's kind of go through this here. Number one, how many samples do you have? One sample. Whenever you have one sample, would it be paired or two sample T? Has to be paired in this case. What are the two pieces of information that they're collecting from each of these 30 adults? Yeah, junk regular mail and junk email. There's one sample, and there are two measurements that are paired for each adult. Each adult answers two separate questions. Junk email, junk regular mail. So I have directionality up here. It could be the other way around, but you have two pieces of data that is paired and subtracted for each of these 30 individuals. So this would be a mu-diff situation. Number two, how many samples do we have? Two samples. What are those two samples? 100 people from the West Coast, 100 people from the East Coast. 2 independent samples. So this would be a mu1 minus mu2, or mu West Coast minus mu East Coast. The last one was a little bit tricky. How many samples do we have? 1 sample. What is it that makes up the sample here?
15 cell phones.
The 15 cell phones. They're from all different kinds of manufacturers. They have different carriers, but it is only 1 sample of phones. What information are they collecting about those 15 phones?
Signal strength in Pennsylvania versus Virginia.
Yeah, so they have signal strength in Pennsylvania minus signal strength in Virginia, or the other way around. They are subtracting that for each phone and then calculating the average. So this would be a paired T procedure. 1 sample of 15 phones and 2 paired measurements. Was this helpful to distinguish? Because I know in a lot of situations in the past, it's like, well, do I do the mu diff? Do I do mu1 minus mu2? If you have 1 sample, but 2 pieces of information, 2 pieces of paired data, you're doing mu diff. If you have 2 separate independent samples, it has to be mu1 minus mu2. Do you guys have any questions for me about this? Give me a quick 1 to 5 rating on your hand. Doing significance testing with mu. How are we feeling about now? All right. That is worlds better than when we were doing this for the intervals or even back to significance testing with proportions. So that's awesome. Tomorrow is weird. Tomorrow we have a Zoom. You get the schedule up on the board here. Your Zooms for first period will start at 8 a.m., so you do get to sleep in a little bit tomorrow. All of the Zooms will be done by 11 a.m. So there's the schedule for Tuesday. This class's Zoom will start at 8:52. You get like 2-minute passing periods because I assume they figure it's only going to take you 2 minutes to click. Use the bathroom before 8 a.m. As far as this class goes, I think I talked to you guys about this last week. You do need to join the Zoom. I'll have a question there that you'll need to answer in the chat. That way I have a record that you were actually here. Other than that, if you don't have any questions at that point, you are welcome to leave the Zoom and work on your review for the test. If you do have questions, if you have points that you want to clarify, or you have questions off the review or off the homework, I will be available to you in the Zoom, but I'm not going to be conducting a lesson. If we were in person that day, it would be an independent work day in class, and I'd be moving around the room answering questions. So I'm going to do the same thing via Zoom tomorrow. And then we still have Wednesday and Thursday in person to review for your test. You guys know what's going on tomorrow? Okay, how do you get counted present? Get on the Zoom and answer the question. Answer the question in the chat so that I have your name, and that way I don't accidentally miss somebody. I can go back and look, and did I see them? I don't remember. I'm going to try to record it at the same time, like right when you are there, but if I have 3 or 4 or 5 people join at the same time, it can be hard for me to keep track of all of that. So answer the question in the chat, that way there is no doubt about whether or not you were there. All right, it's going to be a simple question, like what's your favorite breakfast cereal? What'd you say?